of May. I'm sorry, this is November 2022, paper 1. Okay, we're told to consider a 3-digit code ABC where each of A, B, and C is assigned one of the values 1, 2, 3, 4, or 5. Part A, we're asked to find the total number of possible codes, assuming that each value can be repeated. Alright, so imagine we have 3 spaces, right? First one is A, second one is B, and third one is C. Now we can use any number, and the numbers can repeat. So we have 5 options, right? 5 options. So that's going to be 5 cubed. Okay, which is 125. Now part 2, assuming that no value is repeated. Okay, again, 3 spaces, right? For the first digit you have 5 options, for the second digit you have 4 options, and for the third digit you have 3 options. So 5 factorial. No, not 5 factorial. Anyways, okay, so let p of x equal to x cubed plus ax squared plus bx plus c, where each of, consider the case where p of x has a factor of x squared plus 3x plus 2. Find an expression for b in terms of a. So let's go ahead and first factorize this x squared plus 3x plus 2. So it's going to be x plus 2 times x plus 1. Right. So possible roots are x equal to -2 or x equal to -1. I'm going to substitute each of these and in p of x. So -2 cubed is -8 plus 4a minus 2b plus c, right? And if we substitute in, so this is your first equation. This is of course equal to 0. Now for your second equation, we'll substitute in x equal to -1, and so it will be -1 plus a, right, minus b plus c equal to 0. Now I'm gonna solve this simultaneously, so I'm gonna multiply the second equation with a negative, so the positive is going to be +1, it's going to be minus, it's going to be plus, this is going to be minus. So I'm going to cancel out the c because we want to find an expression for b in terms of a, right? So -8 plus 1 is -7. Then 4a minus a is plus 3a minus b equal to 0. So b is equal to 3a minus 7. Okay. Now in part 2, we're asked to show that the only way to assign the values is a equal to 4, b equal to 5, and c equal to 2. So what you can do is you can find c in terms of a or b and then show that the only possible value that makes sense is 2, since they cannot be 0, right? Okay, so I'm gonna skip part 2. Now part 3, express p of x as a product of linear factors. All right, great. So we now know from part 2 that these are our values of a, b, and c. So you can find p of x, you can write p of x. So p of x is equal to x cubed plus 4x squared. So I'm just substituting in the values of a, b, and c, plus 5x plus 2, right? And we're gonna go ahead and divide this p of x by our already existing factor, which we're given x squared plus 3x plus 2. So it's going to be x minus x cubed minus 3x squared plus minus 2x. So the x cubed cancels out and we'll be left with x squared plus 3x plus 2, and then we'll add a 1. That'll give us minus x squared minus 3x minus 2. So these will cancel out as well. And so if we want to write p of x in terms of linear factor, it's going to be x squared plus 3x plus 2. Sorry, this isn't linear. I'm going to show you. Then multiplied by x1, and we already know the factor. We already factored this out, so it's going to be x plus 2 times x plus 1 squared. So this is p of x. Then in part 4, we're asked to sketch a graph of y equal to p of x. Okay. So we know that the x equal to -2 is an x-intercept, and we know that x equal to -1 is another x-intercept. This is a repeating root, so you have to keep that in mind. And of course, our y-intercept, if you solve it, I just did mentally, is what y equal to 2. So keep that in mind as well. Okay, so I'm gonna try to draw this with the best of my ability. So this is -1, and this is -2. So I guess you can say the function comes from here, right, and then it touches the x-axis at x equal to -1, and then boom. Yeah, that's a rough sketch, but I want you to get the idea. Alright, so that's it for question number 11 of November 2022, paper 1.